Today I am going to talk about Newton's second law by using the electric and the electronic timer. My plan lesson have three parts. Uh, the first part, the first part which I want to show is the objective uh, knowledge of the lesson. The acceleration is directly proportional to the net force acting on the object and inversely proportional to the mass of the object. And about skills, I hope student verify the relationship between the magnitude of acceleration and the force, the net force and its mass. Besides, I also hope my student can conclude the problem. Well, I will follow. I will follow. I follow the second part. The second part is teach strategy. Phase one is elicit the problem. Uh, in the phase in the phase one, we should give the student one situation which connects with the law and make the student feel interested. The situation is a car is standing on the table, which is smooth. If we act the car by a strong force, the car will move rapidly. It means that the acceleration in the case is great. If we still at the same force on the other object, which is bigger than the initial object, the car will move slowly. In the case the case have the lower acceleration. It is because the second car is heavier than the initial car. So many shock experiments show that uh, the magnitude of the acceleration is directly proportional to the magnitude of the net force acting on the object and is inversely proportional to the mass of the object. It is Newton's second law. So the question which I want to ask the student is how do we verify Newton's second law or how to verify Newton's second law? Well, I we follow the phase two, the second phase. The second phase is problems solving the problem. Well, in order to solve the problem, we should use the experiment. Well, well, uh, well, in this phase, we we will know how to verify Newton's second law by using the experiments. The first one, we will create the situation which connect with the law. It is shown in the figure. As we can see the figure, we can see the attract, the true photogas, and the mass M. I will introduce more detail in introduce the more detail the experiment. To verify Newton's second law, we we need to verify two cases. The first case, mm, we will change the force acting on a system object. It means m constant and verify and then verify. The the second case is we will keep the force, the net force is remain and change the mass of the object, and then we also verify the law in that case. In this case, before conducting the experiment, I I will introduce the apparatus. Now I use the air track and electronic timer to verify Newton's second law in two cases. Well, we can see that the apparatus of the experiment include the car, the air track, two photographs, and the mast M is hung at the end of the string. We also need to note that because the force acting on the system is exactly the gravity of the mass m. So in order to change or actually I want to increase the force acting on the object. So we can change the force. We can change the mass m more detail. We can adding to the mass m 50 gram. Firstly, we use the mass m which have 50 gram, and then we measure the time, and then we adding to the mass in the object 50 gram. So the mass m in the object now is 100 gram. So and then we after that we also measure the time. After conducting the experiment in the first case, now we need to verify the Newton's second law in the second case. In the second case, we keep the force acting on the object on the system is constant, and we train the mass of the car by adding to 50 gram, and then we do similarly to the first case to measure the time. Well, we have already conducted the experiment. So there, in the first case, we have f is m is constant, and we change the net force. So in the first case, we need to verify that the acceleration is directly proportional to the net force acting on the system. So if F2 is two times larger than F1, so we have let's see, A2 equal 2 times A1. We denote by second equation. Besides, we know that the equation of the uniform accelerated motion is s is the distance of the object, s equal to v0t plus at squared divided by 2. In that case, we set up v0 equal to 0. So equation become a equal to 2 times s divided by t squared. Let's see. We can conclude that a or the acceleration of the object of the system is inversely proportional to t squared, and from the second equation we can conclude that t1 equal to square root of 2 times t2. Well, we need to verify that. Yeah. To do that, let's see. As we can see the data of the experiment, we let t1 in the first term. In the first term, we let t1 divided by t2 here, and the ratio is approximately 1. Well, because the experiment have error number. Besides, when we conduct the experiment, the effectively of friction force can affect the data. Well, so we have the error number, and the second time we also let t1 over t2 over t2. Also the ratio also is approximate square root of 2. So it is correct. It is correct. So from verifying it, we can conclude that the acceleration is proportional to f. Well, and follow the second case. Case 2 is f. We keep the net force acting on the system is remain constant, and we change the mass. Well, we can follow the second case. In the second case, we change the mass of the system, and keep the force acting the net force acting the object acting the system remained. In this case, we need to note that because F in that case, in this case, the F acting on the system is the gravity. So, and the M, actually M in this case is the M of the system. So we have to change the mass of the system. To do that, we have to change the mass of the car, because in order to change the mass of the car, we can add the mass. Actually, we can change the mass of the car by using the bar, which has the mass equal 50 gram. So let's see. So the mass of system 2 equal 1.191. The mass of system 1, because of the condition of the experiment. So we can only set up the mass it here. It is the bad number. So T2, it is the same case 1. We also conclude that if the mass of the system equal to 1.191, the mass of the system, the initial mass of the system, we also conclude that T2 equal to square root of 1.191 T1. So we need to verify that. To do that, let's see. Here there is the data of the experiment in the second case. The first time we measure T1 and T2. So, and now we let T1 divided by T2, and we achieve the result, which is the approximately about square root of, and it's correct. Well, it's nice, very beautiful. And the second time, we also let set up T1 over T2, and we also achieve the result approximately 1. So from verifying it, we can conclude that the acceleration is inversely proportional to the mass of the object. After we verified Newton's second law by using the experiment, we can conclude that the law is correct.